Hello everyone. Today I'll give you a presentation about my recent work. Um, I'm presenter Yixin Zhang. Today my topic is the cause of northward shift of the Western Pacific subtropical high in summer 2010. The presentation will be conducted in the following sequence. First is the introduction and background of what draws our interest to our topic. Second is the data, method, model that we use in our research. The third section, I will give you a very brief review of the research results in the three topics. First one is circulation anomalies in summer 2018. The second one is relative roles of tropical heat source in generating circulation anomalies, and finally, I will give you an analysis of similar events during the past 14 years. And last, I will give you a conclusion of my study yet. Okay, let's start here. 2018 summer, we have a very unusual typhoon generation in North Pacific because three of the typhoons changed their tracks to attack Shanghai. You have to know that only seven typhoons made their landfall in history since 1960s, when record began, and 2018 has three of them in only 1 month. Apart from the typhoon track difference, severe hot temperature took up the East and Central Asia. China experienced a recording hot summer. The abnormal typhoon track and weather conditions in 2018 summer have caused great loss of human life and properties in East Asia. Thus, we are eager to know that what caused the climate abnormal in 2018. Okay, wait a moment. I'm going to okay, sure. First, we all know that the TC tracks are under the control of Stirling flow. Here we plot mean and anomalous Stirling flow by integrating the 850 to 300 hectopascal mean and anomaly winds. In mean states, we can see that the ridge of subtropic high is located around 30 degrees north. Under the leading of subtropical high Southland typhoon often have two routines. The first one is easterly movement and pointedly direct to South Asia in 10 to 20 degree north, or it will have a northeastward curvature tracks towards Japan. But you can see here in 2018 summer, the anticyclone circulation has a northward shift, and the Stirling flow also moves to north and pointing directly to Shanghai. From the observation, a new science question rises. Since TC tracks abnormal is due to northward shift of West Pacific subtropical high, then what caused the West Pacific subtropical high's northward shift? Okay, the next I will give you an introduction of data, method, and model I utilized in research. Data is basically come from the NOAA and SAP reanalysis 2 database, except outgoing long-wave radiation from the satellites, precipitation from the CPC merge data analysis, sea surface temperature from extended reconstructed V5. And method we use first one is empirical orthogonal function analysis, which we call it UF afterwards. Others are pattern correlation analysis, composite analysis, regression analysis. For the model, we use the European Central Hubble model. We call it ECAM4 model. It's used to simulate how heating source affecting mid-latitude atmosphere. Okay, let's go to the results chapter. First is the circulation anomalies in summer 2018. This is the first study we want to go through, and the left-hand side you can see a panel of anomalous geopotential height and wind anomaly from 850 hectopascal to 700 hectopascal, 500 hectopascal, and 200 hectopascal, from the low level to high level. We can see from that there is an equivalent barotrack vertical structure with northwest, southeast tilting, positive geopotential height anomaly occurred at over 30 to 40 degree north at each level. At the same time, in tropics, you can see a very clear negative geopotential height anomaly appears in tropical Pacific with cyclonic wind anomaly. In a relatively baroclinic structure, you can see it's negative here, positive in the upper level. Under this situation, we conclude that there is a north to south geopotential high dipole occurred in North Pacific region. We also detect other variables of general circulation. The vertical velocity and specific humidity are other two parameters we're interested in. The omega and the humidity both have meridional dipole pattern. You can see here is corresponding with the geopotential height anomaly, where the anticyclone circulation is corresponding with subsidence due to ATMO pumping effect, and downward motion will generate positive omega. We can see there is a positive center in 30 to 40 degree north. And also we can see the northwest southeast tilting is consistent with 2018. On the other hand, when cyclonic wind locating has an ascending motion in tropics. The specific humidity has a positive anomaly appear to the south, whereas a negative specific anomaly appears to the north. This could be explained by specific humidity formulation, where we have positive vertical velocity when the W is larger than 0 and the partial Q partial Z is always less than 0, so the partial Q prime partial T would be positive when we have an upward motion, and thus moisture accelerates over the convergence zone here. Also, the subsidence is corresponding with less humidity. Another point we want to mention is those meridional dipoles well consistent with dropping potential height pattern we mentioned before. The circulation to the north of 40 degree north may have a more complex structure, for you can see there is a upward motion here. Then we detect the vertical meridional profiles. We average the data between the 120 degree west to 150 degree east, and plot the vertical profile from 20 degree north to 20 degrees south to 60 degree north, 1000 to 200 hectopascal. From the mean and anomalies results we show on the left, we could find the positive geopotential height center at about 40 degree north in barotropic structure anomaly, penetrated from the upper troposphere to the lower troposphere. This is the same as what we find in observed horizontal geopotential height anomaly. Also, a much weaker amplitude of negative height anomaly appears to the south in the low-level tropics. The air temperature shows similar pattern with geopotential height. When there is a positive geopotential height to the north, there is also a warmer center. When this is, we call it a good hydrostatic approximation. That is when we have a thicker layer here in 30 to 40 degree north. We would also accept a higher temperature. And when there is a negative center, we will accept a lower temperature. This is a very good hydrostatic approximation. To the omega and the specific humidity profiles we will show here, according to the mid-latitude anticyclone, we could find that there is a positive omega in 30 to 40 degree north, and for specific humidity here, we have a negative center. Meanwhile, upward motion in the lower level, in the lower latitude, and higher specific humidity acceleration here. This is well consistent with the observation. Also, we can take a closer view of what happens at the abnormal ascending motion at the latitude higher than 40 degree north. You can see there is a narrow upward motion at 40 to 50 degree north. But why vertical velocity has such an anomaly at 40 degrees north higher other than the dipole? Here we assume it is a 40-degree northwesterly jet occurring in early summer that determines this kind of circulation. Okay, then we will just have a very quick review of the principle behind. In the main states, a westerly jet occurs center at Japan, and the upper level of the West North Pacific is the jet exit area. Just like that in the 200 hectopascal wind anomaly figure, a jet exit south or south well, a jet in as the jet exits, aerotropic wind will be generated. This point could also be found in previous study by Dial 2019. From the aerotropic wind formulation we show here, you can see that as the jet exit, du dt is always less than 0, and f is always larger than zero, so we could say v is always smaller than 0. Thus, it will generate a southward aerotropic wind. This kind of southward aerotropic wind generates convergence with downward motion to the south and divergence with upward motion to the north. And in 2018 summer, we all know that there is a geopotential height anomaly, and the jet is enhanced by the southwest-northeast tilting anomaly wind. So to the north of the anomaly, positive geopotential height would generate higher, much larger ascending motion, and this is what we find in the period. And it is what we find. And also, let's go back to the subtropical high shift. Outgoing long wave radiation is another important variable we need to investigate. From the outgoing long wave radiation anomaly observation here, we can find apart from the tilting, positive outgoing long wave radiation anomaly corresponding with the pre-mentioned tilting tropic height center, we found 4 enhanced convection center. This is over the negative OLR regions. There are the West Pacific, East Pacific, also in India and Africa. For now, we hypothesize that it is the tropical diabatic heating that is the main reason caused mean latitude positive geopotential height anomaly move to north. This four convection zone will be used in the model simulation to simulate the real-world heating source at tropical area afterwards. And another question is why we have these anomalous convections. Here we make assumptions that is the SST heating that is the main trigger. We can see from the sea surface temperature anomaly. We're showing here the shading is the sea surface temperature anomaly, and for the tropical Pacific, we can see a Pacific meridional dipole, or we call it a PMM pattern here. You see the you can see the cold water to the east and warmer water to the north and west. Also, from the PMM model, there will be generated a cyclonic circulation caused by georesponse, and this kind of georesponse will strengthen the ITCZ convection and thus cause West Pacific and East Pacific heating. Apart from Pacific heating, we have Indian heating. Here we assume it is conducted by the warmer SST in Indian Ocean dipole. Here, warm water and cold water. This process could be seen in many previous studies by Chang and Lee 2001. For Africa convection, we think it's the Atlantic 3 cells. Since SST anomaly may be the trigger of Africa heating, also maybe in the ocean, SST anomaly may also play a role in Africa heating. Up to now, we are still talking about the observed results. So for the next part, we will focus on our model results. The model ECAM4 is utilized to find out whether tropical heating source could excite mid-latitude positive geopotential height anomaly or not, and how they make such a kind of influence. To get the 2018 anomaly pattern, we subtract control run, which is forced by climatology. Monthly mean sea surface temperature for 10 years, and subtract it to sensitively experiments, which is integrated for 30 days. That's with a specific anomalous heating. The four specific anomaly heating is generated by is chosen by outgoing long wave radiation anomaly centers we mentioned before. They are Western Pacific forcing experiments, with Eastern Pacific forcing experiments, India subcontinent experiment, and Africa experiment. Here we separately then name them with WP, EP, IN, and AF experiments. Then we take a look at the model results for each experiment. The first experiment we show here is the West Pacific one. We added the heating to 10 to 30 degree north, 120 degree east to 180 degree. The geopotential height reaction in the upper level 200 hPa and low level 800 hPa is shown in figure B and C. You can see here from the positive geopotential height anomalies at height anomalies here is at 30 to 50 degree north and even could reach 60 degree north, and have an anomalies anticyclone circulation in situ. Positive geopotential height anomalies appear in both lower and upper tropicals. This is in a good agreement with the real-world observation we mentioned before. Negative anomalies is also showing to the south. In addition to the north-high south low pattern, a Rossby wave trend could be seen in upper level 200 hPa, start at 15 degree north and 150 degree west, and stretch towards the north, eastward in this way. This heating excites upper level Rossby wave, and through which energy is transported to higher latitude and cause not higher geopotential height. Also, this forcing could force downward to low-level circulation, and from the low-level circulation looks like it. And next one is the EP result. We give a force of result from 10 to 30 degree north and 108 degree to 112 20 degree west. In both upper and low level, we can see a negative result rather than a positive geopotential height appears in mid-latitude North Pacific, where we expect a positive center. The simulation results indicate that the EP heating is not critical in generating observed circulation normally in North Pacific. Next one is the IN result from India Peninsula. In Indian, we circle the 70 to 90 degree east, 20 to 40 degree north, resulting in a barotropic positive geopotential height anomalies at 30 to 40 degree north in Pacific, and I have to say this gives us a very surprising good result. A negative height anomaly appears to the south of 30 degree north in tropical Pacific, which is well consistent with the geopotential height observation. Also, due to the strong negative geopotential height center is to the north of 40 degree north in both levels, the positive anomaly center is a little bit to the south and relatively narrow. Here we specially plot the 70 degree east to 120 and to 80 degree west to see the Rossby wave trend. Starting from the 70 degrees, the energy transport like a big circle here. and go along the 40-degree north finally to the North Pacific. With trend like this could through the westerly jet carry energy eastward to North Pacific and thus excite a mid-latitude positive geopotential height in North Pacific. Likewise, in Africa, AF heating, which is generated from 10 to 30-degree north, but from 345-degree, I think it's 15-degree west to 40-degree east. This is also give us a very clear north high south low pattern and also a barotropic vertical structure, but a little bit narrow at higher altitude in 200 hectopascal. What carries energy moved to another end of the equator this time also still is the Rossby wave trend. Here we specially plot the global 200 hectopascal anomalous geopotential height associated with wind, and the 40-degree North Silk Road is not far to find. You can see here from Africa, positive, negative, all the way to North Pacific. The energy, so we can have such a kind of circulation in 2018. Okay, like we did before, we also plot vertical meridional profile here, also averaged over the 120-degree west to 150-degree east, showing the 20-degree south to 60-degree north, 1000 to 200 hectopascal. The full experiment outcomes are in the left, and also the geopotential height profile in observation and the right for easy comparison. All of these four experiments show positive anomaly with the equivalent barotropic structure at North Pacific, but they are different in magnitude and arrangement from experiment to experiment. In the West Pacific experiment here, we can see that 30 to 60-degree north all show positive, and has the largest magnitude among all the key experiments. The IN and Africa also have high magnitude in 20 to 45-degree north, but the positive center is a little bit to the south compared with observation due to the squeeze from negative center of the northern dipole. The EP result is the smallest among all. The height response is much weaker, so we don't want to talk too much here. The upper result horizontally and vertically show the shape of circulation. Next, we want to determine how much they separately contribute to total heating results. For quantitatively calculation, we make a box covers the most prominent observed positive geopotential height in vertical to find out the relative importance of the tropical heat source. Here we circle in the red frame. So it's 30 to 50-degree north, 800 hectopascal to 200 hectopascal. From that, we have a new box index calculated by averaging all the geopotential height anomalies inside the box, and then calculate the ratio of the new index to the total positive geopotential height change. The result is in the left table. We can see that, not surprisingly, WP took out most of the contribution. That's 3 in 4 of the geopotential height change is attributed to the West Pacific, followed by Indian and Africa, which separately contribute 12% and 8%. And East Pacific plays the minimal role on the other hand, and with only 5% of contribution. Thus, we can make a conclusion that West Pacific heating contributes the most heat to the northward geopotential height shift. Okay, from the previous proving process, we found a relative complete logic chain. Diabatic heating on the tropics caused northward shift of subtropical high. Stirling flow also moved with that. Thus, the thesis under control of Stirling flow and their tracks also changed to the north of the common year. but there is still some unsolved interesting problems. Last part, we will answer another science question that we are very interested in. That is whether the 2018 event was a unique case or such an event occurred in the past. To handle this question, we conduct UF analysis based on 850 hectopascal geopotential height anomaly during the year of 1979 to 2018. UF is the most common used method to find the dominant modes in a long time period of data. So here is the first four dominating modes shown on the left. Among the four modes, the second one and the fourth one seem to have better pattern. However, um, if we do the composites, combine years, have pieces larger than one standard deviation, or we do the regression methods to the corresponding pieces, show a very good approximation to the real world pattern. And even from the eyes, you could see that they have unignorable differences with observation. The second pattern, it cannot explain the northeast southwest tilting uh, of the geopotential height center. And the fourth mode, on the other hand, is a wave trend. So therefore, we could get to know that the 2018 pattern is not a frequent occur pattern. For UAF, could only separate the mode that happens more often. So to handle this problem, we have two new methods come about to our mind to find whether similar years did exist in the past 40 years. The first way we name it is a box difference index BDI, which is defined as the difference between the geopotential height anomaly averaged over two boxes. Two boxes, we picked out the area where we have the most prominent north high south low dipole mode. So this is north box 30 to 50 degree north, and this is the south box 10 to 30 degree north, and they are in the same longitude from 120 degree west to 150 degree east. The sequence of 40 years difference become a new time series showing here. And these are the 8 years. We picked out have a value larger than one standard deviation. The 8 years 1990, 1994, 1998, 1999, 2000, 2008, 2011, 2012. These 8 years, we take it as the typical north high, south low years. Uh, but uh, but from these years, we have to admit that 8 years is too much for from us to pick up. So a stricter method is also applied. We name it the pattern correlation index. This is most direct measure to reveal whether or not the geopotential height anomaly at a particular year resembles the anomaly pattern in 2018. Here we calculate the pattern correlation of north-Pacific box, which is 10 to 50 degree north, 100 to 120 degrees to 100 to 50 degree west, and calculate the pattern correlation between 2018 and during each individual years. This time for 4 years are selected: 1985, 1994, 2000, and 2060 are selected based on the correlation of one standard duration. Finally, what we do is to figure out the two common years that both indices meet our requirements. They are 1994 and 2000. To prove that these 2 years are both resemble 2018, we do composite of the geopotential height of 850 hectopascal in these 2 years. And the results did rebuild a north high, south low area and distribution. The positive center tilting is also vividly shown here. Another variable we are concerned about is outgoing long-wave radiation anomaly. The negative outgoing long-wave radiation anomaly appears also in tropical Western and Eastern Pacific, North Pacific, North Africa, and Indian subcontinent. All these are highly resembles the heat source we picked before the model, and this kind of similar heat source could give us similar geopotential height response, and thus we conclude that the 1994 and 2000 are 2 years that is the 2018 pattern. But there is still a problem. Though 1994-2000 are both similar years with 2018 pattern, why only 2018 have an obvious TC track change? To understand this, we further took a look at the individual circulation for 1994 and 2000. In 1994, we can see you can see the geopotential height anomalies in 850 hectopascal, 500 hectopascal, and 200 hectopascal. We can also see barotropic vertical structure and also a positive geopotential height anomaly here, and also the northeast southwest tilting. It is consisted with 2018 observation. Also, you can see the westerly jet induced negative center to the north. Corresponding with geopotential height pattern, we can see that in the specific humidity pattern and omega anomaly pattern, where we have divergence, we have downward motion. Where we have convergence, we have upward motion. Also, the specific humidity is larger when we have convergence, and smaller when we have divergence. This is all well consistent. Sea surface temperature, like in 2018, we have PMM pattern in West Pacific here, but it's a little bit smaller and smaller in amplitude. All of this give 2018 like outgoing long wave radiation distribution. But as we could find that in 1994, there is a relatively smaller amplitude and poor combination of ascending flow and moisture. Outgoing long wave radiation is thus weaker and smaller in West Pacific and East Pacific, and thus this kind of circulation hinders the typhoon genesis. In 2000, we also can see the north positive geopotential height center, and it's also about equivalent to our tropic structure, but we cannot see the tilting and the westerly jet induced negative geopotential height. They all absent here. Other variables like omega and specific humidity, you can see that omega have a downward anomaly at 30, though it have a downward anomaly at 30 to 40 degree north, but upward motion is unclear at West Pacific. And for specific humidity, even we have north high, south low, which is contradictory with 2018 observation. This kind of bad specific humidity and omega both discourage typhoons forming. But thanks to the La Nina-like sea surface temperature pattern we show here, in La Nina year, we all know that West Pacific would experience a larger convergence and more rainfall. And thanks to La Nina-like sea surface temperature pattern, West Pacific have a larger convergence in 2000, and thus outgoing long wave radiation also shows negative value in West Pacific and East Pacific. This gives us the circulation that looks like 2018. So 1994 and 2018 both looks like 2018 one, and, but due to their circulation, they cannot generate such a kind of severe typhoon track change. At last, I will give you a quick conclusion of what I have conducted yet. First, in 2018, a meridianal dipole pattern, or we call it a north-south low pattern, appeared in geopotential height, anomaly field in Pacific, leading to the northward shift of West Pacific subtropical high. Accompanied with the northward shift of subtropical high was the enhanced convection over the tropical Western Pacific, Eastern Pacific, Indian subcontinent, and North Africa. Then we used the idealized numerical model ECAM4 experience to show that Western Pacific heating anomalies is most important in generating the mid-latitude circulation anomaly, and it could have such a kind of effects is due to the Rossby wave generation and energy dispersion. And the importance is followed by India, Africa, and East Pacific heating anomalies. Finally, we conduct two new ways and find 2018 event was not a unique event. During the past 40 years, similar events happened in 1994 and 2000. Okay, for future work, maybe we could focus on topics maybe like understand what caused the heat this abnormal heat occur, and whether this original heating origin have something with have relevance with interannual oscillation, maybe like ENSO, and interdecadal modes, maybe like IPO and AMO, and maybe other topics like how Indian and Atlantic Ocean affect land convection in India and Africa in 2018. Okay. And that's all for today's presentation. Thank you for listening. If you have any questions, please feel free to point out. Thank you.